Well, howdy, welcome back to Multar Aviation. So in this Part 7 weather video, I'm going to be talking about global circulations and jet streams. And so in this first video, I'm going to be talking about the global circulations, and in the next video, it'll be about the jet stream. So I'm Dr. Andy Moulter. I'm a flight instructor at CFI-IIMEI. I'm a former corporate pilot, and I used to be a professor of aviation. All right, so in this video, I'm going to be talking about the global circulations of the Earth's atmosphere. And so we're going to be talking about the non-rotating Earth circulation system. And then because the Earth does rotate, then we'll be talking about the rotating Earth circulation system, which includes the Hadley cell, the Ferrel cell, the polar cell. And then in the next video, I'm going to be talking about jet streams. So that's going to be talking about the direction of the jet streams, the location, and the speeds of the jet streams. So the non-rotating Earth circulation system, if the Earth didn't rotate, the air would just flow from the poles to the equator, and that would be it. If you lived in wherever you lived at in the northern hemisphere, the wind would always come from the north, and it would just flow south. And then the air would cool and sink, and then flow back to once it gets to the equator, it would rise. And so I'll go ahead and put up my laser pointer. And so as that air is flowing from the North Pole down to the equator, it would rise and then just flow back up to the North Pole. If you lived in the South Pole area, or if you live Southern Hemisphere, it would flow to the equator and then rise and then just flow back to the South Pole. Well, since the Earth does rotate, the axis is tilted and there's more land in the northern hemisphere than the southern hemisphere, the global pattern is actually much more complicated. So there are three circulations instead of just one large circulation. And the first circulation is called the Hadley cell. So the Hadley cell is a low latitude air movement toward the equator. Air rises vertically with poleward movement, and it forms a convection cell that dominates the tropical and subtropical climates. So if we see here, so from the equator to 30 degrees north, the air wants to flow towards the equator, and then it'll rise, and then it just flows back towards 30 degrees north, and then sinks. And so it's primarily a downward motion of the air. Now, remember in Coriolis force in the northern hemisphere, whenever the wind's blowing, it blows to the right. Now, I don't want y'all getting confused. Right left does not mean east west. So when it moves southerly, it moves to the right. And so when it moves to the right in this example, then it's going west. Now, I want you to remember, as I've said in many of my other aviation weather videos, everything we're learning is just one piece of a puzzle. There's a lot of different factors that go into understanding weather. And if you've been watching these aviation weather videos, you're like, man, I still just don't have a good understanding of aviation weather. That's okay. Aviation weather is just one of those things where, you just kind of have to accept on faith sometimes. I've met with meteorologists before from the Aviation Weather Center, and even they'll say, it's meteorology is an art and a science. And so, you know, to become a meteorologist, you have to do high levels of math. You have to do calculus 1, calculus 2, calculus 3, linear algebra and vector geometry, and differential equations 1 and 2, just to become a meteorologist. Because when it comes to understanding weather, you have to understand math. So it's just one of those things. It's like, even when you get to that point, it's more of like, okay, what has the weather been doing and what can we infer from it? So if you're ever feeling lost with weather, that's okay. Just remember, it's all about just putting all the pieces of the puzzle together. So a lot of what we're looking at in these videos is from a simplistic view, and you have to put all those little points together to make meaningful insight from this information. All right, so the next cell is the Ferrel cell. So the Ferrel cell is a mid-latitude, mean atmospheric circulation cell with air flowing poleward and eastward near the surface and westerly toward the equator at higher levels. So here in the Ferrel cell, it goes from about 30 degrees north latitude to 60 degrees north latitude, and the air at the surface is going to want to flow northward toward the north pole, and then it'll rise and then flow back towards 30 degrees north and sink, And as the air is moving northward, because of Coriolis force, it wants to flow to the right. In this instance, it just happens to go towards east. All right, then we have the polar cell. So the polar cell, air rises, it diverges, and travels toward the poles. Over the poles, the air sinks, which forms the polar highs, and at the surface, the air diverges outward from the polar highs, and the winds are easterly because of Coriolis force. It goes to the right. So we're looking at the North Pole here, and the air wants to move, flow towards the south. And as it's going across the surface here, it's going to rise, and then it's going to flow back towards the North Pole and then sink again. And so here, the air is going to, as it's going down, it wants to flow to the right. All right, well, that's it for this video. If you have any questions, please leave them in the comment section. I'm happy to answer them. And please make sure to subscribe so you get notified when the next video comes out, in which I'll be talking about jet streams. All right, well, thanks for watching. You take care. Bye.